Okay, this is going to be the hardest problem on the first test, but it's not too bad. Maria throws an apple vertically upward from a height of 1.3 meters with an initial velocity of 2.4 meters per second. How long will it be in the air before it hits the ground? Okay, so first thing I'm going to do, I'm going to draw a picture. So here's Maria. Maria's going to have green hair because I want her to have green hair. She actually have pigtails. Okay, so here's Maria. She's throwing an apple, kind of looks like a heart. Throwing it upward from a height of 1.3 meters. So it's 1.3 meters. The velocity initial is 2.4 meters. So after it's being thrown, what is it being accelerated by? The apple shouldn't get faster, right? It slows down because gravity is slowing it down. Okay, so eventually it'll actually be 0 meters per second up at the very top before it comes back down. And then it'll start speeding back up. And actually, when it gets to the height that it started at, it'll be going the same velocity that she threw it up. But now it falls an additional 1.3 meters to hit the floor. Okay? When it hits the ground, it will actually be moving faster than when she initially threw it. So that's something good to know. Okay? So based off our givens, from the picture, we know that VF has to be greater than VI. And we're not talking about whether it's positive or negative. We're actually talking about the number. Okay? Remember, positive and negative just shows what direction it's going. If you notice, VI was going up, VF is going down. So it's actually going to be a negative VF. That's good to know. We also talked about acceleration. And it's going to be acceleration due to gravity. So it's going to be negative 9.81 meters per second squared. And then also from the problem, she throws an apple vertically upward from a height of 1.3 meters. And the picture, it's thrown from 1.3 meters, but it ends up on the ground. So the displacement, remember the shortest point from where it started to where it finished is actually 1.3 meters. Notice it went down, so it is negative 1.3 meters for x. We also have an initial velocity, so a VI, and it is positive, so it's 2.4 meters per second. So she didn't throw it downward, she threw it upward. Okay. Our unknown, we are actually going to be looking for time. Our equation. So we have acceleration x, vi, t. This one's tricky. Okay. The reason why is the equation that has x, vi, t, and a has a t squared and a t. Okay, what that means is you'd have to use the quadratic formula. Although you wouldn't be able to use it because acceleration is negative. Okay, so what you're going to actually have to do, since we saw that we have to solve for t and t is squared, that's going to give us a hint that we have to use two equations for this problem. So instead of actually solving for t, we're going to solve for something we don't know. Okay, so we have acceleration, x, vi, we don't have t. What else can we solve for? We talked about it up here. Solve for velocity final. Okay, so if we solve for velocity final, I'll branch this off again. We can solve for velocity final, and once we have velocity final, then we can solve for t. The reason why is because VF is going to be negative, and that's why we can't do the quadratic formula. So, let's look for an equation that has VF. So this one has VF, this one does not, this one has it, does not, and this one has it. Acceleration It has acceleration, does not have acceleration, has acceleration. X, this one does not have x, so we're left with this one. So our equation must be vf squared equals vi squared plus 2ax. Trying to solve for vf. The opposite of squaring something is a square root. So we're going to square root both sides. We'll be left with vf equals radical vi squared plus 2ax. From here, we're just going to plug in. So vf equals radical 2.4 meters per second squared plus 2 times our acceleration times negative 1.3 meters. Notice these two are negative, and that'll help make it so VF is going to actually be a positive number, but because of this picture, it's going to tell us it's negative. The reason why is because that would be an imaginary number. We don't like negative numbers under the radical. So whatever our answer is, we're just going to stick a negative in front of it. So you should get 5.59 as your velocity final. Sorry, they still haven't returned my calculator. So 5.59 meters per second is our velocity final. Okay, so now this is actually another one of our givens. If you want to add it up there, you're more than welcome to. But notice, remember this t, we did not want to use this equation. So just a word of advice, do not use this equation. Okay, so that one's already marked off before we even start. So first thing we're going to do, look for ones that have t in it. This one does not have t. Those three do. So those are all possibilities. Okay. Next, acceleration. Doesn't have acceleration, doesn't have acceleration. That one has acceleration. Okay, so this one has acceleration. These two didn't. We have VI, VF, T, we have A, or we're solving for T, sorry. So we can use that equation. So we're going to have A equals VF minus VI divided by T. Can you solve for a variable in the denominator? Absolutely not. Okay, so you're going to have to get T out of the denominator by multiplying it, and it's going to put it on this side. So when we sorted it, it's going to be T times A equals VF minus VI. Now we're going to have to divide by A on both sides to get T by itself. It's going to get it rid of over here. And we're going to be left with T equals VF minus VI divided by A. So we're going to have our last step of substitution. And we are going to have negative 5.59 meters per second minus 2.4 meters per second, all divided by acceleration, which is negative 9.81 meters per second squared. Hint, make sure you made that negative. If you did not, it will not give you the correct answer. So you're going to take negative 5.59 minus 2.4, all divided by 9.81. Negative. That should give you an answer of 0.81 seconds is your time. So that'll be the time the ball is in the air.